we are going to do the review for the final. So I'm going to start by giving you as many details as I can, and then whatever we've got at the end, we'll start doing topics. So first question, and Katie's not allowed to answer because she knows the answer. When is our final?
It's the 17th.
And that is correct. Which day of the week?
It's a Friday.
You nailed it. You want to go for 3 out of 3? When? When does it start and finish?
10 to 1. Okay.
You nailed it, right? So that is our final. So let's give you a little gist of what the final's big picture is, right? It's going to be on all 10 weeks. So you could get stuff from week 1. Last thing you'll get is week 10. It's in It'll be in chronological order. That just means your first question is from week 1 and your last question will probably be on the dot product or vectors, right? Because that's the last thing we did. It's approximately 40%, 60%. What I mean by that is the first 5 weeks, right? The stuff you did up to your midterm, about 40% of the points are going to come from there. And then the other 60% is going to be coming from the second 5 weeks, which is what we did from the end of the midterm onwards, right? So if you think of the midterm as cutting the class into 2 halves, 40% from the early stuff, 60% from the later stuff. Make sense? Okay. Now, it's going to have 2 sections, and they're both going to be on Canvas. So there's no WebAssign at all. Right, so you don't need to worry about WebAssign. WebAssign will actually disappear. So if you went into WebAssign, it would be empty. You wouldn't see anything. It's going to be in 2 sections. Section 1 will be 10 multiple choice questions. And they are worth 5 points each. And so that comes to 50 points. And for multiple choice, all you do is tell me the right answer. I don't want to see any working. It won't make any difference. Right? So you tell me it's A, B, C, or D, right? And you pick whatever is the correct answer. So I won't won't expect to see any working. And then section 2 is going to have 10 questions as well. And these ones, you need to show working or you won't get points. Because if you just tell me the answer is pi upon 2, I'm just going to assume you went into Desmos and looked at the picture and said it was pi upon 2, right? Or you did something that wasn't really mathematical, right? You just looked at a picture. So you need to show me working for those questions in general. And these guys are, on average, worth 25 points each, which means it comes to 250 points. And both of these are chronological. So when you look at your multiple choice question, the first one's like from week 1 and the last question will be from week 10, right? So the last question will be in vectors, right? And the first question, who knows, something to do with radians or an angle. And section 2's got the same. Now, there are 10 questions, and on average, they're 25. Most of them will be 25, but you might get a 20-point question, you might get a 30, right? So there'll be multiples of 5, but most of them will be 25, maybe 1 or 2 20, 1 or 2 30s. You get more points if it's a bigger, harder question, right, than if it's a short one. That's the only reason that's there. So that adds up to a total of 300 points. And I think I mentioned it, and if I haven't, I'll mention it again anyway. Sunday midnight is drop dead date for all assignments, online tests, everything. If it's not done by Sunday midnight, it's not being done. And what that will allow me to do is, after classes are finished on Monday, because Monday is a class day, we'll talk about that later, I will make one last report, and that will be sent out. And that report will tell you exactly what you've got done, right? Every point that you've got. So the only thing that's missing is your final. And it will also say things like, you need 220 to get a 2.0, right? And you need 370 to get a 4.0, or whatever it might be, right? Are we okay with that? Right. So that's one of the reasons, amongst others. Another reason why I make Sunday a drop dead date deadline. You've got to get ready for your final. If you're spending the last few days and the last few hours of those days just finishing off homework, that means you've had no time to study for anything. And the final is worth a lot more points than 1 or 2 homework exercises, right? At the big scheme of things, you're probably only going to get an extra % here or there if you do them or if you don't, right? It's not going to kill you one way or the other, but please do them because every % happens, right? But much more important is you get ready for your final. So you need to focus on that, and that's another reason for drop dead date. Any questions before we move on? Are you comfortable? You know when it is, where it is, and all that good stuff. There will be, and that means I can now zoom over to Canvas and give you a kind of what I've got so far. Over in Canvas, you'll see this one here, which is a new module, final exam module, and we'll click on that later. That guy there that I'm now clicking on, let that go away. This fella here, that is the Zoom link, right? Not your class link, but that one, right? So we've got a special Zoom link for the final. And just like the midterm, you need to have your camera working, you need to log in on time. This better don't have it. Good. Your final exam PDF will be here on the day of the final. Right now, it's just a placeholder, right? You will upload your working here. So after you've done all your working, right? I think I may have to go in as a student to do that. So you've done all your working, you've written it down, you've written the answers, and you'll click on this guy and you'll say, start assignment, upload file, choose your file, you choose whatever it is you think you want, hopefully you've got it stored somewhere easy, and then you submit. And that's the last thing you do. And it's done. So I'm using, or I would use Microsoft Lens. Click on that link if you need it. Here are some of the things that are going to be here on the day of the final. All this stuff here, right, will have disappeared. You won't see that either. What will still be left is all of that without the, well, I haven't put it here, but I will put it. See the practice final with solutions? I'm going to put it in this place because that seems more natural for it, but that will have disappeared as well. So apart from that, this is everything that you've got that you can see. So what will you get? You'll be able to use that for polar, that for general graphing, that when you need to deal, say, with a parametric one. So that's basically all you're going to have. So you're going to have to supply your own notes and your own formula and your own whatever else for you. So let me now click on this guy, which hopefully is going to open up, right? Okay. Can I? Is there a way to maximize that? Okay, that's this one. there we go. And basically this just repeats everything that we've mentioned. Here is a list of everything that we've done from the first set of questions all the way down to the dot product. And again, it's just repeating, it's in chronological order. Here is a link. It's the same link that we had, you know, in the module. This is your Zoom link for your final. Once you finish, you've got an extra 30 minutes to upload your work in here. What can you use? Your calculator, any written notes you've got, and that includes people who use, you know, like pads and mark pads and things to write their notes. That still counts as notes. You can have a list of formulas. I would definitely have a unit circle. Would you agree a unit circle is like, if nothing else, if you could only have one piece of paper, have a unit circle, right? Because that's the guy that seems to be, appears everywhere. And you can use anything that I've got in that module. So, you know, I've got Desmos there and the polar graphing and that. Anything that's there, you can use that. You can't use a calculator that's got a thing called algebraic manipulation. If you don't know what that is, you either don't have it or you don't know how to use it, in which case you'll be okay. You can't use basically anything else on the internet. So you're not allowed to go to help pages. You're not allowed to go to programs that can do stuff for you. You're not allowed to contact a tutor or phone a friend, etc., 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 right? So basically, if it's not on Canvas, if it's not on a piece of paper, or if it's not in your head, then it's not there. Right? You can't use it, can't go and get it. I think that's covered everything. Yeah. Is there any questions about that?
For the Microsoft Lens, can we use a different like app that combines everything into a PDF?
Yeah.
Okay, cool, because my Rocketbook does that too.
Right, and there are people who've used Cam Scanner, which is another one. I think it's called Adobe Scan is a third one. Some people just use their printer and scan it that way. I'm not really too worried how it gets to me as long as it gets to me. I just put that one in because that's the one I've got, I like the best, and that's the one I've got a link to. But you can use anything. Next question is the third one.
Oh, also,
yeah.
Sorry. When does WebAssign clear again?
It will disappear in your case sometime Thursday night, probably more likely Friday morning when I remember to. So
okay.
I'll be up there until, you know, almost the exam starts.
Okay, thank you.
Good questions. Any others?
I know for the exam we're getting a PDF, and then we're also have to upload our work to Canvas. For the PDF, do you want us to put just the answer on that, and then upload our work on something separate?
No, I'll give you an example of what it might look like. Right. So I go back. Imagine I was taking the exam. It might look something like this. That's not absolutely necessary because when you upload it, it puts your name on the file, but it's easier if I can see it, you know, when I'm grading it. And then you would do question 1, it was A, question 2, I think the answer's C. Question 3, I don't know, but I feel lucky, so it's a C, right? Question 10, it's a D, right? That's all I will see from the 10 multiple choice questions. And then section 2. Question 1, I don't know what the question was. You find the arc length, it's r times theta. To get the radius, it's 7 centimeters, and theta was 30 degrees, but you knew that you had to turn it into radians. And then you would say S is equal to 7 times 1/6 pi s equals 7/6 pi. So the formula I used, the numbers I used in my formula, the calculation that my formula said, and the best version of my answer. That's kind of the basic shape of almost every question, isn't it? You know, there's things I'm going to use, there's things formula I'm going to use. And for instance, wouldn't you be drawing right angled triangles if there was some SOHCAHTOA stuff going on here? You might be doing an all sine tan graph, all sine tan cos when you were doing something to do with maybe solving an equation and which quadrant it's in. So that's what the working looks like. And, question 10 might be, V is this guy, U is that guy, and you did blah, 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 a whole load of working, and you finish with, the angle between the vectors is 31.1 degrees. That might be what your last question looks like. But working, right? For instance, this one here, wouldn't this have the formula that I would be using would be, hopefully you all knew that, right? Would be that. So I'd be writing down, hey, that's the one I'm using. And, I'd have working for these. These are the numbers I'm using. Plug them in. That's the angle. And you get a lot of partial credit for working. WebAssign is not very nice to you. Have you noticed that I have to go back to almost every test you did and give you extra points? Because WebAssign is like a very strict parent. If it's not perfect, it's wrong, right? So you might just forget, I don't know, you forgot to put a pi in, right? And we all know it's a half pi, and it's pretty obvious from the rest of the work you knew it was a half pi, but you didn't put in the pi. WebAssign will give you 0 out of 12 because the whole answer's wrong, right? And so working is important. So that's why I like to do finals this way. Now, couple of, you're welcome. A couple of other things, since my brain is thinking about advice in general. Multiple choice questions should only take you, or should take you, less than 5 minutes. In fact, the vast majority of them, you should know the answer within a few minutes. So if you look at a multiple choice question and you think, oh, that's going to take me a while because I think I'm going to have to find this, and then I'll have to find that, and then I'll have to find that, you're doing it wrong. If it's a multiple choice question, that isn't the way to do it. So they tend to be pretty straightforward and pretty quick. If you think you have to do it some complicated way, just pick C. It's not worth spending 20 minutes on a question. If it's a multiple choice, it shouldn't take you that long. When you're doing section 2, one advice I think works for a lot of people, especially those who get a little bit nervous during a final, is there's no reason in the world why you need to do the questions in the order I gave you. You might find it easier to do questions 8, 9, and 10 first, because they're the ones we've just done in the last couple of weeks, and they're fresh in your head, right? And you know how to do them, or you're pretty sure you know how to do them. And that's okay. Do it that order. And then maybe you'll look at a couple of questions and you know that you're not very comfortable with them. They've, in homework, you always had problems with them. Why don't you make them the last 2 questions? Right? That's all you need to do. If you do them each on a separate piece of paper, when you're finished, can't you just put them in order and take them in picture 1, 2, 3, 4, 5 all the way down, and everything's fine? So that would be a piece of advice. One of the reasons I'm saying that is that if you were doing it 1, 2, 3, 4, let's pretend that question 3 was a stinker, right? Couldn't you spend 20 minutes, 30 minutes trying stuff out and then just getting frustrated and saying, I know that's rubbish, or I don't know what to do? Now, isn't that going to be psychologically you in the wrong frame of mind for the rest of that final? You've already lost half an hour. You know it's not, what you've written is no use. And now you're looking at the clock and thinking, oh God, I've only an hour to go and there's 7 questions. Not a good mental place to be. So why don't you do all the good stuff, right? Oh God, the vectors, 5 minutes and that's done, right? I know how to do them standing in my head. Aren't you going to feel psychologically much better when you know you've got 3 or 4 in the bag and you've plenty of time? So that's why I'm saying do it that way. But you choose what suits you. That's what I would suggest. Any more questions before we look at topics and maybe start a topic or two? We good? So I'm going to just nip over to the screen again. And here we go. Can I make that bigger? No, that's as good as it goes. Right. Has anyone got a topic they want to start today off with? And here's a big list. Just to, jog your memory in case you can't remember what the thing was called. Any topic in there, any question that comes to mind that's maybe in the homework or whatever.
Can we go over polar coordinates again?
Polar coordinates. Okay. All right, that's a good start. I'll go back to my white screen then. And polar coordinates are in section 8.1 and section 8.2 if you want to go hunting for them. Well, there are a number of different types of questions. I think they kind of boil into like 3 main types. There are questions where you do conversions. That's where you take a point like 5,7 and you turn it into polar coordinates, or you take polar coordinates and you turn them into, 3,4, right? So that's conversions. The second one is sketching them. Those kind of questions are really quite easy because don't you just use the software and you plug them in and you see it? And then the third kind of one is the ones where you take polar and you convert the expression. That doesn't even look like the word convert. Yeah, that's a little bit better. And you convert the expressions. I'm going to start with the last one because that's probably the one that causes the most trouble. So an example, you might be given y equals x squared and be asked to convert it to polar. That kind of question would lend itself really well to a multiple choice because they're relatively quick. Now, you do need to know what the y and the x coordinates are equal to in polar form. So I'll put these guys up here for you. Can you remember doing those two? Remember them now? That the x coordinate is r times the cosine of theta and the y coordinate is r times the sine of theta. And so you go over here and you say, okay, r sine theta, and you go here and you do r cos theta squared. And that's fine. Now, in multiple choice, you have to get the right answer. And that probably won't be any of the choices because there's, I've got to make it look pretty, right? Style points. But if this had been a section 2 question, I guess it could be part of an ABC thing. You've at least got a couple of points by doing this, right? So at least we know that you've got a conversion, right? Now, the goal, if it's possible, and sometimes it's just not, the goal is to write it as r equals, if you can. So r cos theta squared gives me that. And then we have to do, as long as you do it to both sides, it's okay rule. And we have to try and solve this so that there's only one r and it's equal to everything else. And it depends on what's in front of you. Anybody want to tell me what I might be able to do to both sides to get closer to that goal of a single r equals?
Divide by r.
I would. And we'll assume that r isn't 0, because if r is 0, you get the origin. So far, so good.
Could you divide the cosine squared?
It's exactly what you should do. And there is a style point rule that is kind of devoted to polar, but you should use it in other situations. When there's a trig expression, we try and not use fractions. So I don't want to leave this as a sine theta over a cos squared, right? That's not considered good form.
Could it be tan times secant?
Well, let's see what that looks like. Oops, wrong one. Sine theta over cosine theta with another 1 over cosine theta. And this guy is secant, and this guy is tan. And that's the answer that would be in the multiple choice. That might be answer C. Now, to make your life a little bit worrisome, I might well have made that answer A. And you would get to that and you say, hey, it's one of my answers. I must have got it right. But this is considered the best answer. So you see that multiple choice, the wrong answers aren't just nonsense. They're not just random things thrown on the paper and, there's no way you could get that. You have to be aware that when you do a multiple choice, be careful that just because you see an answer doesn't guarantee that you've done everything. Have another look and think, oh yeah, I remember him saying style points, we don't like fractions. I wonder what this would be as a fraction. And then you might see this guy and say, oh, wait a minute, that guy is him. Gotcha, right? So you have an extra 30 seconds, when you're finished to be really finished. Is that the kind of thing you wanted to know, Lena? Anything else within the polar?
What do we do again when one side doesn't have an X or a Y and it's just like a number?
Are we talking about this situation turning it into polar?
Yeah, converting it to polar, yeah.
Okay, and there isn't an X or a Y, there's just a number? Is that what I heard? So would that be something like a Y equals 6 you're talking about?
Maybe, yeah.
If it was Y equals 6, you would just do R sine theta equals 6. And then you could do divide both sides. And then you would say, wait a minute, don't like fractions. And that would be your answer. That's maybe too simple. Can you it doesn't need to matter if it's precise. Could you make up a version of what you're talking about? If you can think of one.
I was just looking one up really quick.
Sure. Matthew, why is Waldo always striped? Why does it always wear stripes? Don't know?
No, I don't know.
Because he doesn't want to be spotted.
That's
I
a
like
really
that
good one.
Yeah, that one's good.
Okay. Cassandra, have you found one, or else we're going to have to move on? You can always tell me tomorrow when you come across one, okay? So no
Okay.
pressure.
Yeah, no,
Okay.
I'll email you about it.
Okay. Okay, another topic, because someone got something that would want me to do next.
I just have like a general question. Like,
Mhm.
so you know like how like there's like the rule like in polar you don't want fractions.
Mhm.
What other like kinds of rules should I remember? Because I can't remember them all.
Oh, God. If we're talking about style points, like making things look pretty kind of thing, right?
Yeah.
The most likely situations that come to my mind would be these conversion ones. So you would be using, in those questions at least, you'd be using the rules, make it look like the original, factor the heck out of it, and obviously no fractions. But you also have to use the identities.
Yeah.
Now, these come in more when you're solving equations. So, off the top of my head, if you were being asked to solve getting hard to make these up. No, take that out, that's easy. Right. Suppose you were being asked to find out the solution to that. There's trig identities that allow us to turn expressions like this into something smaller. Do you recognize this one as one of the double angle formulas? Cos square theta take away sine square theta is the cosine of 2 theta. And then from here I could solve it. That would be an example. Suppose I had this situation. Sine square theta cos square theta plus sine to the 4 theta. Well, suppose I had that. And then it can equal, I don't know, who cares, a half. That guy there can be simplified.
You would factor out sine, right? Sine squared.
Yeah. Now, if you do that, you now get that. And then an identity kicks in. You see it? In this case, the identity is that it's 1. So now you've got sine square theta is a half. Would you agree that is doable? Because then you could take the square root and find what angles are equal to the square root of a half. So you would do something like this. Sine theta is positive the square root of a half. And the other solution would be negative square root of a half. That isn't the way I'd keep that. I'd call that 1 over root 2. And I'd call that negative 1 over root 2. And then make it look even prettier. And do you recognize some guys from the unit circle? And you'd be able to solve that equation. I think it would be pi upon 4, 3/5, 3/4, 5/4, and 7/4 pi eventually. So trig identities allow you to change things into something that allows you to solve an equation. You are more likely to do these kind of things in solving an equation. Whereas when you get the polar, they're normally not as ugly as this. So you normally are pretty much going to just do things like, divide things by r and then maybe, get everything over to one side and then simplify it. And the simplification is get rid of fractions.
That actually answered my question as well, because it's basically the same as x squared minus y squared equals n number. And
right,
so,
and so you end up with this guy.
mm-hmm.
Oh, well, let's show you that is an interesting question, because that can be simplified even more. Because 2 theta is the inverse cosine of 1. And what angle has a cosine of 1? Well, 0 has an angle of cosine of 1, which means theta equals 0. And what else has a cosine of 1? 2 pi has a cosine of 1. So theta equals pi. And you don't need to worry about that one because that one is this one. So what you end up with is basically just that red line there. And if you go the opposite way, you get that line there, which is fine. So that one would have actually became theta equals 0. I think I remember one where it was tan of theta equals 1, and then you said theta is pi upon 4. No. That was
So if,
kind of,
if it asked like what are the solutions from 0 to 2 pi, you would say 0 and 2 pi.
you
and
just
then-
pick 0. Yeah. I would just pick the first one because there should only be one answer.
Oh, but remember like when there's like multiple different answers?
Oh, that's in solving equations? Yes. If they're solving equations, you would give, well, there are two types of answers. There's the one where you would say it's pi upon 4, and you would only do that if they had a restriction like this. But don't you also have I think it's 2 pi k, guys, don't you have that?
Mhm.
In which case you just put a 2 pi k and you would do it that way. These are the infinite solutions. This is just solutions between 0 and, well, I could say 0 to pi and that would reduce your answers again, wouldn't it? It would only be 2 answers. Depends on the question. Yeah, there are lots of nuances on the trig. It's not simply, oh, one rule fits all. It's, you have to look at each circumstance on its own merits and, you know, work on that. I think we get time for one last question. So what you got? Give me a good one. Okay, I'll pick one. Tomorrow you'll have a whole list of things to ask me. Parametric. You could be asked to sketch it, but if it is, don't you just go into, you know, the software and you plug it in. So let's do conversions, right? These are called parametric equations, and our job is to try and rewrite this in terms of x's and y's. Right? It's a conversion question. I'll call this top one equation 1. I'll call this equation 2. One of the techniques that you use a lot is a substitution technique. You pick one of these two equations and you write it as t equals, right? That's your goal. And sometimes you can do it to both, and sometimes, in fact, let's make it so you can only do it to one, and sometimes you can only do it to one equation. So which of these two equations is the only one that you should be able to rewrite as t equals?
X. Oh, sorry, 1.
Yeah, number 1, the x one. So your goal is to get this to be t equals. And let's assume that they tell you something like that, and then we'll see why that's important in a minute. You add 1 to both sides. You divide everybody by 2. You then take the square root of everybody. And since I told you t is positive, do you see we can get around the plus or minus problem? And then you go to y, and that's 2 cosine t plus t. And you replace the t by this guy. So it's 2 cosine of ugly square root plus ugly square root. And that is converting a parametric into what we would call Cartesian.
And you would leave it like that.
Yeah, there's not really a style point you can do to that one. You know, some questions are just ugly, right? You can't do nothing. So that's okay, it's less work. Have we reached a nice kind of finishing point for today? Okay, I'll hang about at the end for any questions that you might just want to ask on your own. I'll see you tomorrow. Tomorrow is going to be another class day. It's going to be registered as such, so you're expected to come. But let me tell you a little bit about Monday. Monday's different. It is a class day officially, but it's a much more open-ended. Everybody gets attendance on Monday, whether you come or not. So Monday is going to be open-ended. What I mean by that is, don't need to turn up. I'm going to assume you're studying for your final. That's fine. You can turn up only to find out how to do this or whatever it is. Yep, I'm good. Off you go and get ready for your final.